when A is a n cross m matrix and B is a m cross n matrix, means we can multiply A to B, it will be size n cross n. Okay, it has sign n cross n, and BA which is sign m cross m. Okay, so we have a two matrix A and B. Two matrix, then non-zero eigenvalue of AB and BA are the same, including algebraic multiplicity. Okay, so we will prove that when AB has eigenvalue lambda, which is non-zero, then BA has also eigenvalue lambda. Okay, and their algebraic multiplicity will be the same. So assume lambda is a non-zero, be an eigenvalue of AB. This implies there exists non-zero x. X is a vector which is called eigenvector. Okay, such that ABX equal to lambda x by definition of eigenvalue, because definition of eigenvalue what it tells us that when lambda is a constant, it can be zero. Okay, this is non-zero and this can be zero, this can be non-zero, but x is always non-zero to be a eigenvector. Okay, so lambda is a constant, any constant, and this is non-zero vector such that if a of x equal to lambda x, if it satisfies, then we say lambda is eigenvalue of A and x is a corresponding eigenvector of A. Okay, so this is the definition of eigenvalue and eigenvector. So by definition we can write it ABX equal to lambda x, because lambda is an eigenvalue of AB. Now multiplying B on both sides, because AB has size, we can see here AB has size m cross m and B has size, we can see here B has size m cross n, m cross n, and AB has size n cross n. Sorry, this has size n cross n. So we can multiply, because column and row this is the same, so we can multiply. So if you multiply this, it will be B ABX equal to lambda is a constant, it will be out, and BX. Now assume BX equal to Y, because it is a vector. Okay, this is a vector. So if BX equal to Y, so we can write here BX is Y, so it will be BAY equal to lambda Y. Yes, if we see that BA, this is a vector equal to lambda Y, and this satisfies the definition of eigenvalue and eigenvector if we show and that Y is not zero. Okay, if we are able to show that this is non-zero, then we can easily say that the lambda is an eigenvalue of BA also. Okay, now if possible, let's assume Y is 0. Then Y we have defined here Y. What is Y? Y is a BX. So BX is 0. If BX is 0, then these equations, if BX is 0, then lambda x is 0. This will imply lambda x is 0. And this will imply either lambda is 0 or x is 0. But by the definition of eigenvalues, x is always non-zero. And by assumptions we have taken lambda is a non-zero. So hence both the condition is not possible. This will imply y is non-zero. And since y is non-zero, then this will imply BAY equal to lambda y. So lambda is an eigenvalue of BA. Okay, so we have proved what? If lambda is an eigenvalue of BA, then lambda is an eigenvalue of BA. AB, then lambda is an eigenvalue of BA also. If we take A is a matrix of this type, means all element is alpha and it is a row vector, means it is a one row and column. And if we take a matrix which is of this, that means column matrix, and we take it alpha, means it is n rows one column, so we can multiply. Here AB will be of the size 1 cross 1. Okay, so it will be constant matrix. We can multiply here alpha alpha dot dot alpha, and this is column matrix. Okay, so if we multiply both matrix, we get what we get. Okay, so alpha square plus alpha square plus dot dot alpha square, and it is n alpha square. Okay, and if we find matrix BA, okay, so size of the matrix BA will be what? N rows one column is B, and matrix A has size 1 rows and columns, so it will be n cross n matrix. So if we find BA, it will be alpha dot dot alpha, and we have to multiply with matrix A, which is alpha alpha dot dot alpha. So if you multiply this, we get the matrix of this type alpha square alpha into alpha alpha square dot dot will be alpha square, means all element will be of this type. Okay, so we can see that here AB is 1 cross 1 matrix and B is n cross n matrix. So we can see here that our eigenvalue of AB is only n alpha square, and if alpha is non-zero, if alpha is not equal to 0, n alpha will be non-zero. So non-zero eigenvalue of AB and BA will be same. By previous theorem we can see non-zero eigenvalue of AB and BA is same. So n alpha square is the eigenvalue which is non-zero, and it is eigenvalue of BA also, and of course it is not zero. So what are the zeros eigenvalue? So 0 0 dot dot zeros are the zero eigenvalue of BA, because what we left here, that non-zero will be only n alpha square, so 0 are the other eigenvalues. Okay, so we have found all eigenvalue of this type of matrix, which will be n alpha square and 0 0 dot dot 0. Okay, so thank you for watching.